Blockchains are like isolated islands. They can't access external data like stock prices or weather information. Your smart contracts can't just call an API to get Ethereum's price. That's where oracles come in. They're the bridges that bring real-world data onto the blockchain. Price oracles power everything from lending protocols like Aave to DEXs, derivatives, and even dynamic NFTs. Now, traditionally, you had two choices for getting price data. Push oracles continuously update prices on-chain. They're always available, but expensive. Every update costs gas, whether you need it or not. Pull oracles fetch data on demand. They're gas efficient, but complex to integrate, and the data isn't always available when you need it. It's like choosing between keeping your AC running 24/7 so that your house is always at the perfect temperature, or only turning it on when you get home and waiting 20 minutes to cool down. But ERC-7412 introduces a third option, a hybrid model that's like having a smart thermostat that learns your schedule, pre-cools your house right before you arrive, and only uses energy when needed. ERC-7412 is still in review, but popularized by protocols like Synthetics. RedStone's ERC-7412 implementation. The way that RedStone's ERC-7412's implementation works is that prices are stored on-chain for immediate access, but only updated when they become stale. Each price feed has a time to live. As long as the price is fresh, within the time to live window, your contract can read it instantly with no extra cost. But when the price becomes stale, the next transaction automatically triggers an update. The user pays a bit more gas for that transaction, but everyone benefits from the fresh data. This can reduce oracle costs by 60 to 90% compared to traditional push oracles, while maintaining the reliability and availability that DeFi protocols need. All right, let's jump into the code. So we're going to navigate to ethfeed.sol, and we see that we're extending RedStone's base contract. We only need to implement two functions, getTTL and getDataFeedID. The getTTL function defines how long our prices stay fresh. I'm going to set this to 30 seconds so that you can see how it works. The getDataFeedID function specifies which assets we're tracking. In this example, we're using ETH. Over here, we have a standard multi-call as it's required for this implementation of ERC-7412. Now we can go and execute this on the client side. We're using a testing framework called Jest. So within this code, we're basically taking the two contracts that we've created. We're starting up a local Anvil instance. So this is our local network. We are then deploying these contracts to the network. We are then calling the latest answer function that is part of the ERC-7412 standard. And we're using the SDK that RedStone has provided to pass along this information to make this call. Once this call is made, we then read this answer from the contract directly. If it's within the time to live, then you can retrieve the price feed information without having to re-execute and refresh the data. All right, now let's see how it works. First, we want to install any packages, and we want to build our contracts. Now we want to actually execute the test. We can see that the ETH feed was deployed, the multi-call was deployed, and that the price was fetched. So now we can go over here to ethfeed.garfield.test, and we see that we have the same code as before. Now we're deploying to Garfield testnet rather than the local Anvil network. Over here, we've preset the ETH feed contract address and the multi-call address. We're actually going to change this contract address and show you how to actually deploy. But it's the exact same test, except this time we try to read first. If the read fails because the time to live expires, then we can proceed with getting the latest answer. And then finally, we accomplish a read at the very end. Now we can go into the README and copy this deployment script. All right, and we've deployed it. Now let's go back to our test and let's go directly to this contract address. And then we will run the test. Awesome. And now the price was fetched. If we re-execute this, it should be much faster because we can read the answer directly, as the time to live did not expire. But if we wait 30 seconds and execute the same function, then we've updated to the latest answer. Now again, we can run this function multiple times and it'll give us the same answer in a very short amount of time. But again, after the 30 seconds, after we retrieve it, we actually have to submit another transaction because it no longer is valid. So there you have it. RedStone's ERC-7412 hybrid oracles combine the reliability of push oracles with the efficiency of pull oracles. You get gas efficiency, real-time data, standard implementation, and automatic updates, all while reducing your operational costs significantly. If you're building a DeFi protocol, I highly recommend checking out RedStone's ERC-7412 system. The links to their documentation, GitHub repo, and supported data feeds are in the description below. If this helped you build better DeFi applications, smash that like button and subscribe for more cutting-edge blockchain development content. Thanks for watching, and I'll see you in the next one.